Okay, so now let's start summarizing alcohols and carboxylic acids. Now, this is the second installment of the organic chemistry. Now, alcohols and carboxylic acids are only for the O-level students, okay? Only for those taking O-level combined science chemistry. Now, first things first, again, it's general formula. You can't run away from that. So let's start with that. So alcohol, CnH2n plus 1 OH. So why plus 1? It's because one of the hydrogens is already at the end. It's very important there's an OH at the end. Okay, the reason why we leave the OH at the end will become clear immediately once we go through the functional group. Okay, so alcohols is CnH2n plus 1 OH. Okay, now carboxylic acid is complicated. It's Cn minus 1 H2n minus 1 COOH. So why is there this minus 1 which makes it look so strange? Of course, we are minusing 1 because you must realize there is already one carbon inside the COOH group. Okay, so it's very important to realize that, hey, there is a reason why we have separated out OH for alcohols and why we have separated out COOH for carboxylic acids. And this is because the functional group of alcohols is the OH group, also called the hydroxyl group. Okay, whereas carboxylic acid C, double bond O, single bond O, single bond H. So this is how we draw COOH, which is the functional group called carboxyl group. And that's why it's called carboxylic acids. Okay, now, very important part of alcohols and carboxylic acids before we get to the reactions is how to draw. So to learn how to draw, we are going to use two examples, one of each homologous series. The first one we should try is ethanol. As the name suggests, ethanol has two carbons. Eth means two carbons. So how would you draw this? Always lay out the carbons at the start. I have two carbons, I just lay out two carbons. Okay, that's the first step. Now, after you lay out the carbons, the next step is to draw the functional group. The functional group is OH, as we have said. OH. Now, that's it, right? There's no double bond, nothing. I have already drawn the functional group OH, so everything else should be a single bond. Now, ensure that every carbon atom has 4 bonds around itself. And now, let's fill in the ends with hydrogens. And so, ethanol, if you calculate, C2H5OH. So again, we will single out the OH at the end. This is so that there's easy visual reference that, hey, this is an alcohol because it contains the hydroxyl group. All right. Now next, let's do a carboxylic acid. Let's do propanoic acid. So now if you look at the name, prop means N equals to 3. Okay, 3 carbons. Let's draw 3 carbons. 3 carbons. Now let's draw the functional group. Be careful. The functional group is COOH. So do we layer on and add in one more carbon other than the 3? We shouldn't, right? It's already stated here. It's 3 carbons. That means the COOH, the carbon of the COOH is already here. This is it. The carbon of the COOH is one of the 3 carbons. Do not add any more carbon atoms. Once you have drawn 3 carbons, leave it. The carbon of the COOH is one of the 3. Okay? Now, so once we have drawn a functional group, the rest are all single bonds because it's not an alkene. They don't have carbon-carbon double bonds. Making sure every single carbon actually has 4 bonds around itself. And this is the structure of propanoic acid. Now, if you calculate the formula, you will get C2H5COOH. This is where most students will make the first of many careless mistakes with carboxylic acids. Now, you will realize that we love to test carboxylic acids simply because there are careless mistakes that students will often fall for. One careless mistake is, how many carbon atoms does C2H5COOH have? Many students, once they look at this formula, will say, oh, there are 2 carbon atoms. But are there really 2 carbon atoms? It's C2, sure, but there's one more carbon in the functional group. So it's very important to realize for carboxylic acids, you must look at the functional group. You must realize there's one carbon atom there as well. And therefore, there's a total of 3 carbon atoms. And that's why the name begins with prop. That's why it's called propanoic acid. Even though it's C2, okay, but it's not just 2 carbons because there's one more carbon in the functional group of COOH. Okay, so I shall pause for a short while to ensure they have taken this down. These are very commonly tested molecules, how to draw. Very common careless mistake about carboxylic acids. Remember, there is one carbon in the COOH. Okay. Now, beyond just drawing and the general formula and the functional group, we will need to know reactions. Now, before we go on to reactions, let's learn how to prepare or make. Okay, so making or preparation of ethanol. So how do you make ethanol? Now, firstly, we need to know ethanol is made from glucose. Okay, glucose. Now, glucose is found in plants. So we extract the glucose from plants. Okay, plants made glucose by photosynthesis. Okay, so like sugarcane plants. Sugarcane plants are very rich in sugar. Okay, so sugarcane plants are commonly used as a source of sugar or glucose. And this glucose in the sugarcane plant can actually be turned into ethanol. Now we're going to focus a little bit of attention on this. This is particularly important. Okay, you will need to know how to describe this entire process. Now, first things first, you need to know the process is named fermentation. You will need to know the equation. And this is where you absolutely have to make full use of what you have learned so far. You will need to try your best to learn the equation. So first, we have C6H12O6. That's glucose. So this is the chemical formula of glucose. We use it as an aqueous solution. Okay, so we dissolve glucose in water. Now, this will form ethanol. Ethanol is C2H5OH. At the same time, it forms CO2. To balance the equation, oh, sorry, I've left out the state symbols. I'm so sorry. Let me just add on the state symbols. Ethanol is also aqueous. CO2, of course, is a gas, carbon dioxide gas. To balance the equation, we need 2 in front of ethanol and 2 in front of CO2. Okay? Now, so this is the equation for fermentation. Now, it's very important to also know the conditions for fermentation. So what are the conditions? When we say conditions, we mean what else do you need? What temperature do you need? Fermentation takes place at 37 degrees Celsius. That's the temperature. And in the presence of yeast. So these are the 2 conditions for fermentation. 37 degrees Celsius, yeast. So these are the conditions. Okay, and there are 2 conditions here, of course, you can see that. All right. So now you will need to know, okay, there are a few things I need to know. Why 37? Why not 40? Why not 60? Shouldn't the higher the temperature, the better, the faster? That doesn't work because 37 degrees Celsius is the optimum, the best temperature for enzymes in yeast to work. Now, this reaction works because there are certain enzymes in yeast which help to speed up the fermentation process. So, if the enzymes don't work, then the fermentation doesn't work. It won't happen. Importantly, too high a temperature will denature. It denatures the enzymes. What it means is that the enzyme changes shape. Denature means to change shape. If the enzyme denatures, it will not work. Fermentation will stop. Okay? So that's the why 37 degrees Celsius. Next, This reaction requires absence of oxygen or air. So actually, this is one more condition to add on. Absence of oxygen. Okay, so there are actually 3 conditions to be fair. Okay, let's make it 3 conditions. Okay, 37 degrees Celsius, yeast, and absence of oxygen. So why must it be airtight and absence free of air? This is because oxygen can oxidize the ethanol. Alcohols can be oxidized, and alcohols can be oxidized simply by the oxygen in the air. And when it's oxidized, it forms the carboxylic acid. So ethanol forms ethanoic acid. That's not what you want. You want ethanol. You do not want ethanoic acid, so it's very important to make sure there's no air. Okay, so you have to find various ways of stoppering, of sealing the setup so that it's airtight, so that there's no oxygen present. Okay? And finally, this reaction does not give you pure ethanol. It gives you a very low percentage, a very low yield. That means you don't get a lot of ethanol through this process. Why? It is because too high ethanol concentrations kills the yeast. Yeast is a living thing. If there is so much ethanol present, the yeast dies. Okay, and that, of course, causes the fermentation process to stop. Okay, now if you notice what Mr. So has done here, Mr. So has basically summarized fermentation. So if you notice, if you read your TYS, okay, if you go to, let's say, year 2019 or 2016, all right, there will be questions that just ask you, describe the process used to prepare ethanol from glucose. 5 marks. How do you get the 5 marks? It's by naming the process. The process is fermentation, writing the equation, naming the 3 conditions, and explaining why these conditions. By explaining the why, you are able to write a very good paragraph that details how ethanol is made from glucose. So I will pause here for a while for you to get all these details down, ensure that you've understood these details, okay, before we move on to the reactions of alcohols. Okay, so I hope you have had the time to pause and really take everything down. This is actually a very important process for us to know as well, because that's how we make ethanol. Now we move on to the reactions. Okay, now the reactions of alcohols are not difficult. Okay, alcohols undergo 2 types of reactions. First is combustion. Now, if you have missed our alkanes and alkenes video, I advise you to go back and take a look at it. Combustion, there are 2 types, complete and incomplete combustion. Over here now, I'm talking about complete combustion. So, how do we do complete combustion? So again, ethanol, C2H5OH, ethanol, 2 carbons, right? Plus oxygen. Now, if it's complete combustion, it forms CO2 and H2O. Leave some space in between so that at least you can put the numbers in front later on. Now, whenever you are balancing combustion, always balance the carbon with CO2 first. 2 carbons, therefore 2 CO2. Now, next step, 5 hydrogen, 1 hydrogen. That's 6 hydrogen. Please count carefully. Remember, there's a hydrogen in OH as well. Okay, so this makes 6 hydrogen, and therefore 3 H2O. It's not 6 H2O, but 3 H2O, because 3 times 2 equals 6. The last step is always to count the oxygens. So we have 7 oxygen atoms on the right. So now we got to be really, really careful. The functional group also has 1 oxygen, right? There's 1 oxygen atom in OH. There's 1 oxygen. So now I need 6 more oxygen. Therefore, 3 O2. So that there's 6 oxygen, there's 1 oxygen here, and so this balances the equation. C2H5OH plus 3O2 forms 2CO2 plus 3H2O. This is the equation for the complete combustion of ethanol. All right. So like I said, systematic. First step, balance the carbon. Second step, balance the hydrogens. And third step, count the oxygen atoms on the right, then on the left, carefully. All right. So that's the first reaction. And now we move on to the second reaction of alcohols. All right. The second reaction is oxidation. So alcohols undergo oxidation. This is very, very crucial. Alcohols are oxidized. Now, they can be oxidized by two things, either acidified potassium manganate 7. Okay, this is an important one. Now, if we use acidified potassium manganate 7, purple color becomes colorless. Okay, the color change if alcohols are oxidized by acidified potassium manganate 7 is that the acidified potassium manganate 7 at first was purple, it will turn colorless. This is a telltale sign that, oh, the alcohol has been oxidized by the acidified potassium manganate 7. Okay, so this color change is very important because it means that I can test for alcohols by simply adding acidified potassium manganate 7, because alcohols will decolorize potassium manganate 7 from purple to colorless. Now, other than potassium manganate 7, I could use oxygen in the air. Okay, oxygen in the air also helps to oxidize alcohols. Now, they are oxidized to form carboxylic acids. Okay, so the alcohols become carboxylic acids as the alcohols are oxidized. Okay, now at this juncture, I would like everyone to learn very well the color change with acidified potassium manganate 7. Okay, alcohols decolorize acidified potassium manganate 7 from purple to colorless. It's alcohols that can decolorize and react with acidified potassium manganate 7. Okay, this is commonly again a point of confusion. You have to associate acidified potassium manganate 7 to alcohols when you are learning organic chemistry. So alcohols decolorize acidified potassium manganate 7 from purple to colorless. And actually, that's all for the reactions of alcohols. Now we move our attention back to the last homologous series, which is carboxylic acids. Now, for carboxylic acids, the reactions are really, really simple because they react like all acids will. So you have learned acid reactions in Sec 3, right? You have learned, for example, acid plus metal, right? It forms salt and hydrogen gas. Acid plus base forms salt and water. Acid plus carbonate forms salt, water, and carbon dioxide. Now, in particular, the reaction with carbonate is quite useful for an acid. So now, let's look deeper at the carbonate reaction. Now, a very typical acid, we can use what we did just now, is propanoic acid, C2H5COOH. The carbonate we commonly use in the lab, sodium carbonate. So let's recall a little bit of formula writing. Sodium is group 1. Group 1 loses 1 valence electron, so it forms Na+. Carbonate is CO3 2-. You will need to memorize this. Therefore, the formula is Na2CO3. You need 2 sodium ions to balance out the double negative charge on carbonate. Now, the H2O and CO2 shouldn't be difficult. The difficulty is the formula of the salt. Now, the salt must contain the metal sodium. it must also contain everything in the carboxylic acid except the H. The H went to form the H2O. All right. So the H went to form H2O. So we have to know that the salt contains the metal and everything in the carboxylic acid minus away the last H. So what is it that I'm talking about? Oh, sorry. Maybe I use a thicker pen ink so that we can see this clearly. So we copy out C2H5COO. Drop the last H. Then we put the Na. Okay. So let me just draw this clearly so that you can see this clearly. All right. So we basically drop the last H from the carboxylic acid and attach it with sodium. Now, this works because, why can we drop the last H? Because we have learned in Sec 3, acids produce H plus ions in water, which means everything else that remains is a minus charge. So it's C2H5COO minus in order to balance out the positive on H plus. And that's why it makes sense that it's C2H5COO minus with Na plus, one of each. Finally, we need to balance the equation. So if you look carefully, it's not balanced. What's not balanced? Sodium is not balanced. There's 2 sodiums on the left. It's Na2, CO3. So I need 2 Na on the right. But if I have 2 Na, I will also have 2 C2H5COO. So put a 2 in front of the carboxylic acid as well to balance the equation. Now, you must be able to write this balanced equation. But what's more important about the aqueous sodium carbonate is that if I add aqueous sodium carbonate to carboxylic acids, carboxylic acid will react with the aqueous sodium carbonate. And when it reacts, there's a few things. You know CO2 is produced. CO2 is a gas. The gas will escape. So what would you observe? The first thing you will observe is bubbles. But we don't say bubbles. Chemistry, chemical term, effervescence observed. Now, the effervescence, of course, is effervescence of CO2. This is CO2 gas. It produces or forms a white precipitate in lime water. So this is a particularly useful way to tell if something is a carboxylic acid. Just add sodium carbonate. If you add sodium carbonate to the carboxylic acid, it should give you effervescence and you should see a white precipitate formed in lime water. Now, this is the test for carboxylic acids. Very important to note this. Okay? And that really brings us to the end of the summary of alcohols and carboxylic acids. Again, I would advise you to read through the alcohols and carboxylic acids notes once more thoroughly, given by your subject teachers, so that at least you get all the details down. But this is a good starting point for your summary to understand organic chemistry. Now, before we close, please take note, this is the second video. It's on alcohols and carboxylic acids. You may wish to rewatch it so that you clear your doubts about these 2 homologous series. But there is also a first video that we did on alkanes and alkenes, which also covered lots of details in organic chemistry, which will be important for you. So by watching the 2 videos together, you should have summarized the bulk of organic chemistry, which will form an important section of your N levels as well as O levels. Okay, so thank you very much. I'll stop the recording here. Thank you.